Okay, example 7 is talking about Newton's law of cooling. So we are going to first talk about what Newton's law of cooling is. So we have T of T is equal to T sub m plus T sub 0, subtract T sub m, multiplied by E raised to the negative K times T. Okay. T sub T, this is the temperature of the object. Okay? The temperature after the object or liquid, substance, whatever, has cooled. Your T sub m, this is the room temperature, basically. Your T sub 0 is your initial temperature. It's the starting temp. E, we already know. K is some constant number. And T is the time elapsed, or elapsed time. Okay, so let's talk about a problem dealing with Newton's law of cooling, that we have to use Newton's law of cooling to calculate. Okay, so we have an egg. Let's say it's a hard-boiled egg, and it was a temperature of 96 degrees Celsius. So an egg at 96 degrees Celsius is placed in water to cool. Okay. 4 minutes later, the egg is 45 degrees Celsius. And we want to find when the egg will be 20 degrees. Okay, so we're going to use Newton's law of cooling. So, my time, I'm going to start with this first situation, and then we are going to solve it for K, so we find our constant. And once we have our constant, then we can calculate the time for the egg to be 20 degrees Celsius. So, at first, I want to know, or I have, that my egg dropped to 45 degrees. So that's the beginning of my formula. I know that my temperature is 45 degrees. And the next part is the room temperature. Well, in this case, it was placed in water to cool. Oh, and it did tell us that the water was 16 degrees Celsius. So let's plug that in up here. 16 degrees Celsius water to cool. So that's my room temperature, basically. I mean, it's the water temperature. So I'm going to plug in a 16 here. And the formula tells me to add that to the quantity of my initial temperature. So the egg started at 96 degrees. Subtract the room temperature, or the water temperature in this case, which is 16 degrees, and multiply that by E raised to the negative constant times the time. Now they told us how long it took the egg to cool down to 45. It was 4 minutes. So I'm going to plug in a 4 for my time. Now we need to solve this out to find our K. Okay, so let's subtract our 16, and that gives us 29. And 96 subtract 16 is 70. E raised to the negative K multiplied by 4. Okay, we're going to divide both sides by 70. And so we get 29 over 70 is equal to E raised to the negative K multiplied by 4. Okay, well, I need to undo my E, basically. So the inverse of E is the natural log function. So we had 29 over 70 is equal to E raised to the negative K times 4. And I'm going to take the natural log of both sides. So natural log of 29 over 70 and natural log of E raised to the negative K times 4. Okay, now my natural log and my E are going to cancel each other out. And so I'll have the natural log of 29 over 70 is equal to, now my exponent moves down to K times 4. And if I divide by 4 and divide by 4, this will give me my value for negative K. And so then I just move my negative or divide by my negative 1 for the other side. Anyway, this is going to give me 0.253. And so my negative 0.253. And so my K value is going to be positive 0.253. Okay, now that we've found K, we can solve the rest of the problem. It wanted to know when the egg was going to be 20 degrees. So I go back to my Newton's law of cooling, and this time my temperature I want it to be, or my temperature that it has cooled to, would be 20 degrees. Okay? My temperature of the water is still the same. It's still, the water temperature is 16 degrees. The initial temperature, again, is still the same. It started at 96 degrees. And I need to subtract the water temperature. And then this is E raised to the negative. Now I have a value for K, so I don't have to write K. So I can put 0.253 times T. And T is what we are trying to find. So we can solve this out to find T. Okay? So subtract my 16 and I end up with 4 equals 70 E raised to the negative 0.253 times T. And so I'm going to divide by 70. 4 over 70 equals E to the negative 0.253 times T. And then take the natural log of both sides. And so I have the natural log of 4 over 70 equals negative 0.253 times T, divide by my negative 0.253. And my T will equal whatever that is. And if I look, it gives me an answer of 11.8. So it will take 11.8 minutes for the egg to cool to 20 degrees.